So remember that when you guys have your number on the outside or end of the function, it's outside of the absolute value bars. That's going to be your up versus down. Addition is up, subtraction is down. Very straightforward. Then when you have the number inside of the absolute value, that's when you guys have to think opposite of what you would normally expect. When you guys see plus something on the inside of the absolute value, that's left, and when it's subtraction, it's right. Remember, it's the opposite of what you would expect when it's inside. Then we have our reflection when the negative factor or multiplication is on the outside of the function, it's reflected to the x-axis. When it's on the inside of the function, it's reflected over the y-axis. And then we have our stretch, which is when you multiply times something greater than 1, and your compress, which is when you multiply the front of the absolute value by something that is between 0 and 1, like a small fraction. So that's just a really quick review of the transformation. So we're going to do the same kind of thing that we did before. The absolute value parent. Okay, so we're also going to be talking about something called a slope. A parent function. The parent function is what your equation would look like if no transformations have taken place. There's no up or down, there's no left or right, there's no stretch, there's no compression, there's no reflect. So what do you guys think the generic absolute value function looks like? Okay. Well, y equals absolute value of x. So every time we learn a new function, we're focusing on absolute value this unit. Every time we learn a new type of function, we're going to learn the parent function, which should just have a y and just have an x. And then because it's absolute value, we put the symbol there for absolute value. So parent function is just y and x and any other important detail you need to distinguish this between the graphs. Alright, and then remember that an absolute value graph should make a V shape. All of your absolute values should be a V. So keep that in mind. Alright, what we're going to do is just look at these functions and figure out what the transformations are, one by one. So just like we did last class, I'm going to circle all of the extra things that are there, besides the x and the absolute value bars, and then those will represent our transformation. So I have the negative. Okay, I have to read something more. Alright, so I have the negative. Remember how we separate the negative when there are two numbers? So the negative, the 2, and the 3. Each of those is their own transformation. What does the negative on the outside do? Reflect over which axis? X-axis. What does the 2 do in the front? They stretch. Stretch 2. When you guys are multiplying the very, very front by a number, besides the negative, that's something separate. If it's bigger than 1, it's a stretch. What about the plus 3? It's on the inside. Left 3. Remember, when it's on the inside of the function, inside of the absolute value bars, you would normally expect plus to go right, but when it's inside, you have to think the opposite, so instead. Alright, what about this one? This one's a little bit interesting. I'm dividing by 2. It is a compressed. Good catch. So usually when you guys are dividing by 2, isn't that the same thing as multiplying times 1/2? Yes? So you could also write the function like this, if you wanted to. Don't say that you're compressing by 2. Say that you are compressing by 1/2, because that's what the factor is. You should think of it in terms of multiplication. So when you guys see division, rewrite it, so it's really, instead of divided by 2, it's just multiplying times 1/2. Okay, so compress by 1/2. And then what does the little -1 do? Because it's inside the function, you're going to go right 1. I think the opposite is what you would expect. Alright, how many transformations do I have in this next one? I have 2. I have a -5 on the inside and a +1 on the end. What does the -5 on the inside do? Right by 5, and then the +1 at the very, very end outside. Up 1. And the numbers at the very end, that's your up versus down. Alright, how many transformations do I have in this next one? There are 3. So 1/3, the factor of -1 is going to be x, and then the -5. What does the 1/3 do? Compress. What is the factor of negative, you're multiplying by a negative on the inside. It's a reflection. If you multiply by a negative, it's a reflection over which axis? Y. Now this is where you guys have to be careful. This is that special case from before. When your multiplication of a negative number is inside, you have to think opposite of what you would expect anymore. No, this is that special case where now this negative kind of cancels out the opposition that we have to think about when we're looking at the next transformation. So if this negative wasn't there, we would typically say that was going to the right. So with this negative, it's actually going to the left. So again, remember in your notes, I asked you guys to add a little, from last unit, add a little note. If there's a subtraction in front of, or not subtraction, sorry, if there's a negative as a factor in front of the x inside the absolute value, then you no longer have to think opposite. You won't see that often, but make sure you're prepared to address that if you can. Alright, what about for the next one? Okay, so this one is reflect. But because that factor of -1 is on the outside, it's an x-axis reflection. And then plus 10 on the very, very end. Okay, and then our last one. Another reflect, another factor of -1, but this time it's inside. Y-axis. And then the -2 on the very, very end. Yeah. So again, not new, we're just seeing it now in the context of absolute value. Everything works the exact same way as it would have in Unit 0. Okay? So in addition to looking at just the function and determining what the transformations are, we're also going to look at the picture, the comparison. We did this in Unit 0 too. So you guys will be given the parent function, which you guys just have to value of x, plain and simple. And then you're going to have the transformed function next to it, and we're just going to describe what transformations took place. Okay, so let's take a look. Remember, this is where you guys use your reference points. You can see that the vertex is right here, and then it goes there. How did you see that? How did it go from the origin to where it is now? It went down 2. Don't say over. Right. Say over, I don't know what direction you're going in. To the right one. Now, is that the only thing that changed where the vertex was? See how it went like that? Is that a compress or a stretch? It's compressed. Remember, we're doing vertical, so when you compress something, it will flatten out. So when you guys are trying to determine how much it was compressed, that's when you guys compare the slope. The slope between the first 2 points on this graph, as it usually will be, is up 1 over 1. You guys see that? You go up 1 over 1 to get to the next point. What do you have to do to get to the next point on this graph? Up 1 over 3. Then it would be compressed by 1/3. Whatever the slope is between the first and the second point, that's going to be how much you're compressing. So it's a change in slope, really. That's what happens with a compression stretch. Yes? I did this one first. I went up 1 over 1, and then from this one, I would go up 1 over 3. You compare the vertex to the point, to the next point over on the right. Any questions about that first one? Okay. How did this one change? This is where I started. This is where I ended up. It's not go down. I went right 1. I can see it shifted to the right by 1. And then it goes up. Up 3. Did anything change? It reflects which axis? It goes like that. X-axis. If you kind of visualize that flip, whatever the line is that you're reflecting over, that's the axis you would use for your reflection. So reflect over the x-axis. That's why it's facing down instead of up. But did anything else change about the slope? Is it still 1 to 1? Is it still 1 each time, like a block? Okay, so yeah, that's where the negative comes from. If you were to write the expression, it comes from the reflection, but you want to make sure that the distance is the same, the block 1, 1. Okay? So no stretch or compress. Any questions about that one? Yes?
Does it go up before it gets up here?
Go right to. Anything else? No. It literally just shifted over to the right. What about this one? It's a stretch. You guys see how I got skinnier? Like that? It's a stretch by how much? Should be 2 or 2 over 1. Because, or wait, it is, actually I think it's 3. I can't tell because it's so blurry on the screen. Is it 2? I'm going to check it really quick. It is 2 from what I wrote. So we're going to see that, even though I can't really see it. Anyway, so when you guys notice that the slope was 1 over 1, then you can see it's skinnier. It's going up like this. It's going to be a stretch. Remember, a stretch has to be greater than 1. So if you say like stretch of 1/2, would that make sense? No. So make sure when you guys notice that it's taller or kind of pulled up like that, that's going to be your stretch when you touch and curve. Did it do anything else? Up, down, left? Okay. That's it for that one. So you guys need to be able to recognize transformations both from the function and from the picture and be able to write them down coherently. Alright, so we're going to do something also that we did in Unit 0. So I'm going to give you the transformations that I would like you to write the equation. Okay. Remember the parent function is always y equals, and you have the absolute value of x. I'm going to start with some space, give it some space, and then start off that way. Now, what would I add on? How do I do left 1? I have a plus 1 inside of the absolute value. Left. How do I do up to? Where? At the end. Outside. That's where up and down go. And then where would I put a vertical stretch of 4? Very, so like right here? Right in front of the x? Outside of the absolute value. Right in front. That takes care of all 3 of those transformations. Alright, what about the next one? Okay. So because it's reflected over the x-axis, that means that negative should be at the front, in front of the absolute value bars. And then how do I do right 1? Inside. Opposite of what you normally expect inside of the absolute value. Alright, what about compressed by 1/2? So because you guys are reflecting over the y-axis, the negative needs to be inside of the absolute value bars next to the x, or in front of the x. The compressed should always be at the very front before the absolute value bars. So if you compress with it. Alright, what about the next one? Which we gotta be careful. So y equals. Because we're reflecting over the y-axis, we have the minus inside of the absolute value bars in front of the x. And remember, when that's there, you no longer have to think opposite of what you normally would for a left or a right. So because we're going left, you just put the normal minus there. So again, an important detail to pay attention to. The reflect over the y-axis and the opposition thinking you would do for inside the absolute value to cancel each other out. Questions about that? Okay. Then our last concept, again, this should look really familiar. This is the exact same chart we would have seen over and over again in Unit 0. I just stuck an absolute value picture in there. Same stuff we were talking about before. We're going to do the exact same thing over and over and over again. Okay? So we're going to start with domain and interval notation specifically. So if I want the domain, you guys want to reach graph from left to right. What's the furthest x value you will reach on this graph? Negative infinity, because it's going forever to the left. What's the furthest right value you're going to get on this graph? Positive. So how would I write the domain? All real numbers. Negative infinity to positive. Alright, for the range, that's up versus down, okay? You want to read the graph from the bottom up. So what's the lowest value on my graph? 3 right here. This is where my graph starts at 3. So the lowest value is 3. What's the highest value on my graph? Infinity. It's going to go up forever. So how would I say that it's going from 3 to infinity in interval notation? Square bracket, because we're including 3. You can draw a little point there. It's on the graph that's included. Comma. That's what your domain and range should look like. Shouldn't be brand new. Should be familiar with that. Alright, now we're going to do local maximum and local minimum. So because this only has, I know we talked about this hill and ditches, but the pointy could still work for a hilltop or a ditch. So you'll notice that there's only one of those. So you're either going to have a minimum or you're going to have a maximum. You're not going to have both because there's only going to be one hilltop or one ditch. So which one am I going to have, a maximum or a minimum? A minimum, because this is a ditch. See that? So I don't really care about the maximum. I care about the minimum. Now I know it says local minima. That means that it's one of the low points. We could actually refer to this as a absolute minimum because it is the only low point on the graph. There's a difference between local and absolute, where it's one of the low points and the lowest point. But we're going to focus on local now. We'll kind of focus on absolute local later. But what would I call that point? You guys can write it as a point. Yep. So I'm just going to refer to it as a minimum rather than just local versus absolute, just minimum. So the minimum on my graph is 2, 3. That's one. Alright, here comes increase, decrease. Alright, so remember you guys want to use your colors that are highlighting. So I'm going to have one color for decrease, one color for increase. This is going to be much more simple than we've seen before because there's only one of each. Graph you've seen before, there could be multiple, so we're going to have one of each. One part's decreasing, one part's increasing. Now, once you guys highlight the actual graph, remember we draw that line, okay? We draw a line where the colors change. Wherever the colors change, you want to take a vertical line and go straight down the middle. Just build a division. And then we're going to highlight the x-axis, okay? On this side of that line, should it be red or green? With your graph, should this part be red or green? Red. And is that part increasing or decreasing? It's going down, so it's decreasing. Then on this side of the line, that's the green part. That's increasing. So use your color coding just like we did before. And then we're going to turn those into intervals. Okay. Increasing is the green part. So the green part of my x-axis, where does the green start? 2. Everybody, 2. That's where the black line is, so 2. And then where does it stop? Infinity. It doesn't stop. It's going to continue going forever to the right, even though we can't see it. The graph keeps going. So my increase starts at 2, and then goes to infinity. Real simple. Just look at the graph where you colored it in, write it as an interval, and you're done. Very straightforward. Remember, only parentheses, please. You should never have brackets. And then decrease. Remember, we're reading our graph from left to right. What's the furthest left? Where does my decrease start? Negative infinity. And then it comes along like this. Where does it stop? 2. Because when you're actually at this point, you are neither increasing nor decreasing. You are standing still. Alright, any questions on increase, decrease? It's much simplified compared to what we did before in absolute values, just one of each. Okay? Alright, what are my x-intercepts? We don't have any, do we? Is my graph touching the x-axis? No, so if it's not going to work for you, if you don't have that part in your graph, you're straight none. You don't always have every single one of these details, so you're just writing none if it's missing. Yes? No. You're going to have to actually write that. Okay, what about a y-intercept? There is one. There is one. You guys can figure it out yourself. Use the slope. So the slope is what? It's up 3 over 1, right? So you guys can do that again. You just need to go over one more time. So you just go up 3 more and go over 1. What does that get you on the axis? At 9. So even if you can't see it, there still will be a y-intercept. Just got to use the slope to go further. So our y-intercept would be 0, 9 if you continue the slope going up. It's 3 more up from 6 and then over 1 gets 9. Alright, what about zeros? None. If you guys don't have x-intercept, you can't have zeros. Those are tied very closely to they mean the same thing. Alright, end behavior. Remember, end behavior is just looking at the arrows on the ends of the graphs and telling me where they're going. What does x arrow infinity mean? To the right. So they're saying, on the right side, my graph is going, it's going up, right? You can write the word up if you want to. But in symbols, what's our symbol for up? Infinity. Our y values are going up towards infinity. What does x arrow negative infinity mean? X arrow means it's on the left side, because x is your x-axis. If you're going to the left, what's happening on the left side? You're also going up. You can have the same end behavior. You're both going up. So both of your end behaviors for f of x and y would be infinity. Alright? Same stuff you saw before. Any questions? Okay, let's do another one. Question, Dan? No? Oh. Oh, they're going infinitely. If they go to the graph and have an arrow, just means that the picture was cropped. And absolute value always goes forever. Alright, so now we're here. View picture. What's my domain? Negative infinity to positive infinity. That is always the case for an absolute value. It's not the case for every single type of graph, but for an absolute value, the domain should always look like that. Okay? Now, what about the range? Remember, range is bottom up. So it's my lowest y value. I'm starting down here with my arrows, so that's negative infinity, that's my lowest, and then what's my highest? 3. So I go from negative infinity to 3. Do I include 3? Yes. If you can physically draw a little dot there and say that's part of the graph, that's on the graph, that would be part of the range. So bottom up, you start with negative infinity, which is down here at the bottom, and then you go. Alright, does this graph have a maximum or a minimum? A maximum. It has a hilltop instead of a ditch, so don't care about the minimum. What would the maximum point be? Negative 2, 3. That's not an interval, that's a point. I know intervals and points are really simple, but this is a point. Okay. Alright, now we're going to do increase, decrease. This part going up, this part going down. So highlight the different sections, whether it's going up, whether it's going down, and then you're going to take a black or just a plain color and draw a line straight down through where the color changed. And then you're going to shade the x-axis and label whether it's increasing or decreasing. Use your color coding to your advantage. You could also help yourself out if you just automatically write negative infinity over here and positive infinity over here so you can visually see that. That may also help, so feel free to do that. So automatically label the ends of the x-axis with infinity. Alright, so I'm increasing on the left of my graph. So where does that little green section start? Negative infinity. That's why labeling it can be helpful. You can physically see that and where it starts. And then where does it stop? Negative 2. So from negative infinity until negative 2, that's where my green part, my increasing is. Just between those two things. Then where does my red piece, the decreasing, where does that start? And then it goes until So again, you guys can see the same number shows up. It's just where one ends and the other one starts. It should have the same number. Questions about increase, decrease? Alright, what are my x-intercepts? How many do I have? 2. Then what's the one on the left? Negative 5, 0. So on the test, you have to write an x-intercept as a point. You have to. The definition of x-intercept is as a point. That's part of the test. What about the second one? 1, 0. What would my y-intercept be? 0, 1. Also must be written as a point. And then what are my zeros? X equals negative 5, 1. Zeros is when you guys write x equals. That's a little equation, but x-intercept should be points. Alright, and behavior. This is the right side of my graph, so what's happening on the right? Don't say decrease. Where's the arrow pointing? Down. So how do I say that the arrow is going down in notation? X arrow, negative infinity. What about on the left side of my graph? Same thing. The arrow on the left is pointing down. These arrows. Down, down. Negative infinity is the book. Okay? Questions? Again, everything that we talked about today is not brand new. We talked about it in Unit 0. We're just applying it to absolute value.